So we're going to continue lesson 6.4 with more modeling. In the last lesson, we saw modeling linear, quadratic, and exponential functions. You can maybe make a guess on what we might model next, what type of function. But we can actually, that's our first question here, is determining what type of model based on context. So what we have is we have the average temperature by month in Milan in 2021. And so we have temperature in degrees Celsius and months. So based on this model or this context, just the context, this situation, what type of model do you think would be appropriate? And I hope that you've guessed that a sinusoid might be appropriate, a sinus as a sine function or a cosine function, because it increases and decreases and it continues to go up and down and up and down. So maybe this is the data for 2021, starts at a low point in January, goes up to August, July, where it's super high, back down to December. But if we wanted to go into 2022, it would then increase again and then decrease. And so we have that ever periodic cycle happening. And so I think a sinusoid would be a good model. Sinusoid includes, so we spell it like this, sinusoid. So the sinusoidal model includes, we could use a sine or a cosine function, or both included in sinusoidal modeling. And we'll talk about which one we'll choose in a moment. So what we want to do is first, we're going to actually find a sinusoidal model without using our GDC, maybe for some basic calculations, but we're not going to use regression. And what we have is we're going to let T of M represent the temperature. So this is the temperature in terms of the month at the nth month of the year. So January would be the first month of the year. So 1, February would be 2, March would be 3, and so on down to December, which will be 12, the 12th month of the year. And we do need that to be a numerical. We need the months to be numerical in order to create a scatter plot and find a model. And so we turn the months into a numerical variable 1 through 12. So now what we want to do is, let's go ahead actually and practice graphing the scatter plot first in the calculator, just so we can see what this looks like in the calculator. So if we go to the scatter plot, remember first we go to open a new document, and you want to go to lists and spreadsheets, number 4. You go up to the very top where we have A, and I'm going to put an M there for month. And I'm going to put a capital T for temperature, or lowercase, changed it to lowercase. That's fine. So we have month and temperature. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 months. So 1 through 12. And please do this with me. Don't just watch. I encourage you to follow these steps. The calculator parts of these exams are often the most challenging. And I think one reason why is because students just watch rather than actually participate in following the instructions with me. So take some time, type this data into yours as well. Hopefully I'm not making a mistake. I don't think so. Okay, you can pause as much as you need to enter yours in. Okay, you can pause now or not. Now I'm going to add a page. So you're going to control add page. What I'm pressing is on the left side in red, and you'll add a data and statistics page. We want to see month, add variable on the bottom. So I'm going to add month. Those are the 12 months. And then on the left side, I'll add the temperature. And that's looks pretty sinusoidal. You could imagine this pattern would continue. So what we want to do now is write a model for this sinusoid. Now, the first thing I'm thinking is I think I'm going to want to use a cosine model, because I like the way I have a minimum down at 1. So maybe if I took a cosine model and just reflected it vertically, then cosine usually has a y-intercept at a maximum. This one looks like it's kind of starting or at a minimum. So I think I'm going to use a reflected cosine model. So I'm going to keep that in the back of my mind. So in order to write this model, we have a couple new formulas that you should be able, or that you should know. And we're going to write this in the form again, T of M equals A times the cosine of BT plus C plus D. Okay, to find what A is, and this is a T here, yeah. To find what A is, we know that the absolute value of A is the distance from that midline to a maximum or a minimum. And the formula to find the value of A is to take the maximum value minus the minimum overall value and divide it by 2. So if I do that for this data over on the left, my absolute maximum is 24.4. And my overall minimum is January at 2.2. And you can, if you don't believe me, we can look down. Yeah, December is 3.3. So maximum minus minimum over 2, which gives us 11.1. Now, notice that I do say that that's the absolute value of A, because A can be positive or negative. I'm actually going to let A be negative 11.1 for this problem. And that was, again, because when I looked at this model, it kind of looked like it had this shape, which is a reflected cosine function. So I'm going to let A be negative 11.1. The next easiest value to find is D, where the midline is. And D is the maximum plus the minimum value over 2. It's the average of the maximum and the minimum. It's right between the max and the min. It makes sense. It's the midline. It's the average of the maximum and the minimum. So the absolute highest value temperature we had was 24.4 plus 2.2 over 2, which gives us 13.3. And that is our value of D. 13.3. Okay, next is the period. In order to find B, I'm going to need to know the period first, because remember the formula, period, or I think we have B equals 2 pi over period. So that is our formula, 2 pi over period. Well, it also makes sense then, we can rearrange this formula to know that also period is equal to 2 pi over B. I can kind of reverse the position of B and period. I can multiply by period on both sides and divide by B. So period is also equal to 2 pi over B, and that's going to be useful. Either one of these formulas can be useful. For this problem, I'm actually going to use the first one, B equals 2 pi over period, because logically I should understand what a period here is. How long is the cycle of temperatures in terms of months in Milan? Like, how long will it be from minimum to minimum again, or from a maximum temperature to another maximum temperature? Well, we're on a 12-month schedule. We know every 12 months we start a new year. And so the period here is 12. Since the period is 12, then I can find what B is. Period equals 12. So B equals 2 pi over 12. And I can simplify that to pi over 6. And then the last part is finding what the value of C is. Well, remember we have a formula that the phase shift, so let's write this below. So I have step 1, A, step 2, D, step 3, we found B. Step 4, we're going to use the formula that phase shift is equal to negative C over B. We have that formula already. Phase shift is equal to negative C over B. Well, my phase shift is going to be 1 unit to the right here, because I can see that I'm looking at a cosine model that starts at a minimum. Well, my minimum starts at 1, not on the y-axis. It's actually shifted 1 unit to the right here. And so I know that my phase shift is actually a positive 1. And so if I substitute positive 1 in for phase shift equals negative C over B, B is pi over 6. I can multiply both sides by pi over 6 to get rid of the denominator here. So times pi over 6, which gives me pi over 6 times 1, which is pi over 6, equals negative C. Or also I have C equals negative pi over 6 by multiplying by negative 1 on both sides. And so now I have all my parts of this model. So I can write my final model. It is temperature in terms of month is equal to A, which was negative 11.1. We should have written that down, times cosine of B, pi over 6 times M, month is the independent variable, plus C. Well, C is negative pi over 6, so minus pi over 6 plus 13.3. And that should be our model. Now, the really cool thing that we can do now is go to our calculators, and we can actually graph that function on the scatter plot and see how well it fits. To do that, you want to press Menu, Analyze, and for plot function. So Menu, Analyze, for plot function. The function was negative 11.1 times cosine, so trig, cosine of pi over 6. Remember, in the calculator, we have to put an x, so times x, not t, minus pi over 6 in parentheses. So that was the phase shift. And then we have plus 13.3. Plus 13.3. I know you can't see it, but I did type it. Plus 13.3. And you can actually see how well that model fits that data. So we just created that on our own. Looks like a pretty good model. This was out without even using regression. This is going to be a big part or project in your IA. So this is a great video to watch and rewatch as you write your IA. You can also, right now, let's go ahead and right click your function. To right click your function, put your hand on top, and right click should be, I believe, Control Menu. So if you put the hand on top, I think you can press Control Menu. If this works, great. If not, we can look at it tomorrow. But you can change the color of the line to a different color if you want to. So that's kind of cool. I'm going to change it to red so I can see it a little bit, stand out a little bit more. All right, that's it for part 1.